I'm Michael Krigsman, an industry analyst and the host of CXOTalk. I'm speaking with Fred Laluyaux, who is the CEO of Aera Technology. Hey, Fred, how are you? And thanks for taking a few minutes with us.
I'm great. Thanks for having me today.
Fred, tell us about Aera Technology. And also, I'm really interested in why you joined the company as CEO.
Aera is the cognitive technology that enables what we call the self-driving enterprise. What we're building is this new generation of applications that are following the same characteristic: real-time and always-on, connected outside and in, thinking and autonomous. That's the high-level principle of Aera. So very smart software that has some level of autonomy.
You're a veteran of enterprise software. You're a serial entrepreneur. You've worked for some of the largest organizations in the enterprise software world. And so how is this different from a transactional ERP system, for example?
You have to realize the problem we're tackling, right? I mean, why are we doing what we're doing, and why do we believe so hard that something is about to change? Think about the world of enterprise software. 40 years of investment in transaction automation in ERPs, on top of which we have, invested tons of money in business intelligence and planning and optimization software. You look forward 40 years into this journey, and the reality of our customers is what? They're spending 2 weeks to try to get an answer to a question that can be as simple as, when is this order going to be ready to be delivered to that customer? Why is that? Why is it so complicated? Most of the companies we're talking to have dozens, some go more than 100 different ERP systems. I'm talking about very large companies. Those systems don't talk to each other. There is no cognitive, there's no intelligence that connects all this transactional data. So you end up with very big silos. You end up with very heavy hierarchies. When you want to make a decision, it's very difficult to measure the impact of that decision on financial, operational, and risk metrics, right? And that's the reality of information workers today. I joke, but I call our generation the laptop generation. Why? I was born and raised in my career with a laptop, and I use this device 15 hours a day to try to provide basic answers to some fairly simple questions. That's the problem that we need to tackle. And we find a way to do it by leveraging what we call internet scale technology that brings together all this transactional data coming from all those different data sources, blended with external sources as well, and bring all of that into what we call this cognitive data layer, which is an intelligent information layer that connects all the different dimensions in my business and gives me real-time visibility into my business operations. On top of which, I can now build a series of skills that are leveraging AI and machine learning or rule-based modeling with very cool UI and NLP to have this real-time interactions with the data.
You're aggregating data across disparate systems.
Yes.
And then you are using cognitive technology to, can we say, operate on that data, or what are you doing to that data?
Yeah, so it's exactly right. So the first part of the problem, again, going back to our self-driving analogy, right? The first thing is, how do I get my data to fuel the brain? And that's where everything breaks in the enterprise world, because I'm using, again, dozens of different systems, ERPs and other systems of records. So the first thing I need to do is translate all this data into a common language. And once I have this single instance that pulls in real time through thousands of crawls every day, pulls all this data into that single layer, I can start doing any kind of business planning, optimization, visualization that I need to do on an ongoing basis. So very pragmatic applications. Right now, we're deploying our technology for an available to promise use case. So a large pharma company wants to be able to tell their customers where their orders will be available for deliver. We're working with other companies on shelf availability issues. We're working with perfect promotion issues. We're working with demand forecasting. We're looking for supply demand matching optimization. all those pragmatic use cases in the world of supply chain. And the reality of our customers is to come to us and say, look, we have $10 billion stuck in inventory right now, right? We need to reduce that number to 8. And the traditional stack of, ERP plus applications plus people doesn't allow us to get through that wall. We need to rethink the architecture. We need to rethink our app to have them running intelligently in real time if we want to be able to get to the next level of performance optimization.
Why can't they use their existing system to get this data? Because isn't that what the existing system is designed for?
You look at a supply chain, you look at a manufacturing process, goes across geos, you will end up with open orders with no matching inventory. Great. Very simple problem. I need to find inventory to convert that open order into revenue. But how do I do this when I have 54 different ERP systems? That's not simple. And I need to go and say, okay, predict my demand? So I use, our algorithms to demand predictions. When I've got that number, I have to look at, do I have excess inventory somewhere? Well, that's not a simple answer to get when you have all these different systems. But assume that I don't have excess inventory. Now I'm looking at my production capacity. Well, I can make the same product in multiple areas. What are the cost implications? What are the SLA implications? So the nature of a business is fairly complex. We are realizing basically the promise of the ERP from 30 years ago by actually truly bringing all this transactional data into a single level. So you could say that in a way we are fulfilling finally the promise of the ERP by removing the complexity of this different system, bringing all this data into the cloud, into a normalized environment, and having a single logical process, which we call the decision process mapping. We can map how decisions are being made around demand optimization, planning, and so on and so forth, and automate that in real time. So in a way, we're actually fulfilling that initial promise.
Fred, okay, so you are pulling together data from these multiple systems, but there's that AI, machine learning, cognitive layer. Where does that come into play?
We're bringing massive amount of data, billions of rows of data into that environment. We tie the data together into what we call this, as I said earlier, this cognitive layer, where the data is tightly connected and tied. So I can look at a customer, know which product they bought, know which components go in the product, know where I sourced the component from, and so on and so forth. So that entire value chain is now connected. So there is AI in that process. But also, as I mentioned earlier, we're building lots and lots and lots of data that needs to be then analyzed and optimized. We run predictions, so demand forecasting. We're going to do a lot of applying the standard, algorithms to that. Where it gets really interesting, in my opinion, is when I combine that cognitive data layer with what I call usage data. Remember that the whole idea is to optimize our decisions are being made. So if I come to you with Aera and I say, Michael, I've identified open orders in Brazil that have no matching inventory, but there is good news, there is excess inventory in Mexico, and Aera has calculated that if you move that inventory to Brazil, you'll be able to convert another $20 million of revenue. Would you like to do this? That's a decision I'm putting in front of you as the system is learning how you think and what decisions you make. And that decision is made in the context of financial, operational, risk, environment that I also, as Aera, understand. So I understand the context of your decision. I understand now capturing the decision that you're making. And over time, I'll be able to measure the impact of that decision, how it was intended, but also unintended consequences. So I'm merging now two data sets. One that's really purely cognitive transaction data that gives me the context of your business and allows me to identify opportunities for optimization through our recommendations. But also I learn, just the self-driving car is running around the streets to learn. I'm learning from the decisions that you're making. And that is pure AI and ML. We're also using those technologies to engage with our users. The goal for us is to become the platform where decisions are actually being made. And for that, I need to be real time. I need to be highly usable. I need to have an Alexa or a Siri type, usability. but in the context of very complex business decisions. So it's pretty much everywhere. And we could not do what we do without these technologies.
So, as the user engages with the system, over time, the system starts to see the patterns, the type of decisions that the user is trying to make, things like that.
That's exactly right. And this is not something that, so we start by, just like a self-driving car, we start teaching Aera using some process mapping, very basic stuff, if-then statements in a fairly complex tree. But ours, our ability to look at multiple systems and so on and so forth. So you start with that, but then you learn as people make decisions, what decisions are just the right ones. So it doesn't mean that you always make the right decisions. We're able to measure the impact of that decision over time and get back to you and say, hey, Michael, be careful. Every time you're trying to optimize for this, you actually dig a hole here. And that's, again, it's all algorithm based.
And thus the self-driving enterprise, because you've got the data from across the enterprise in these various systems that you're bringing together.
And for the system to learn, or any intelligence to learn, you need to have a memory. And if you think about what we fail as enterprises for the last 40 years, is to build that memory. Every time, every year, we start a new cycle. This planner moves from that job to that job. This sales manager goes from that function to that function, or that region to that region. And you lose that memory. So you restart constantly. And what I think we need to create in order to really get to the next level of performance optimization in the broader sense of the world is building that permanent memory over time. 3 years later, when a planner goes from one product to another, you don't leave with your memory, you leave your memory behind. And that's fundamentally important if we want to have learning systems that become a lot more intelligent.
Right. Okay, Fred Laluyaux, CEO of Aera Technology, thank you so much for spending a few minutes with us.
Thanks for having me today. Thank you.